You there? Well, who knows how to put Twitch chat on. If you do know, hit me up on Twitter. Let me know, because, yeah, no idea. Anyway, so I have made a beginning to this code. Well, it is very much at the early sort of hacking phases and getting something implemented, something that works, and then we'll refine it later. But yeah, so what this code is doing, I've got some code elsewhere that is currently logging loads of cryptocurrency values amongst other data points in a big database. So that will ultimately interface with the code we see here. However, it's it's not at that point yet. So what do I need to do next? The init function is, it's been a while since I've looked at this. The init function is getting various bitcoins or trading pairs. So the environment, I should say, works in a few ways. With the way the reinforcement learning agent, the way it will interact with this environment that I'm creating, it will initialize the environment and then call this reset method to sort of get the environment in a working state. So this reset method at the moment will generate absolutely random time series data for the bitcoins. But obviously that's just a filler. You can then add in your own data when that's ready. And then after you've reset the environment, you can calculate the transaction cost. Sorry. After you've reset the environment, then you'll call step on the environment, which is this method here. And this step method will take an agent action. It will run it into the environment, make that action on the environment. The environment will change based on that action. This is very indicative of a lot of the reinforcement learning literature. So you only have to Google reinforcement learning to find lots of good information on this that will explain it a lot better than me. I'm just giving a very quick and high level overview of what's going on. So every step the agent will make an action on the environment, and that's the thing I'm implementing at this moment. Like what happens when the agent makes an action, and what is the action? In this case, the action is a weighted sum of its portfolio. So what that means is, for every coin in its portfolio, it passes in a set of let me start again. So for every coin in its portfolio, it gives a possible weighting or a percentage of all of the coins it would like. So for example, it might have 3 coins in its portfolio, and it could give any weighting to each of the coins as long as they all add up to 100%. Anyway, so at the moment we pass in the action, we check if it's greater than, if we round too many steps, because we want to make sure we can run lots of versions of the environment. So let me add a step limit. Okay, cool. So add a step limit that can change. That's variable. That's arbitrary at the moment. We'll look into that later. So if the actions are sensible, i.e. they're in the right dimension, remember we are trading a specific amount of coins, and we need to pass in a set of numbers that says, okay, allocate this amount of our portfolio to this coin, this amount to that coin, this into that coin. So check that our action is correct, and then we have to work out the cost of our action in terms of transactions. So, okay, I've got 50% of my money in Ethereum, and I want to move that to 70%. How much does that cost, given this current time step of value? So, this previous point in time, how expensive would it have been at that point? So that's what that's doing. And we're here we are adding the transaction cost to the reward. So that's not very sensible. I'm going to get rid of that because we want to minus that from the reward, really, in some manner at the very least. So let's not do that. Let's say, okay, so that's how expensive our thing is going to cost. Okay, so the next thing we'd have to do is work out how. The next thing we'd have to do is work out how to so I'm going to now need to work out what the actual value of the portfolio is. So at the current time step, what is the portfolio? Then once I have my new value of the portfolio, I'm going to need to subtract the cost, the transaction cost, from the new value, and I'll have my total value. So okay, and then I guess so the reward is kind of how do you reward your network? That's an interesting question. So I mean, one way is you could sort of just keep on adding up and summing up the total value. So let's put 4 decide on how to reward our agents. So what are the options? You could sum each time step of total value, or you could just pass pass the current value. Yeah, okay, cool. So let's implement number 2. At the current time step, what is the value of the new portfolio? So what do we have to represent the portfolio? So the portfolio is the action, which is cool. So once we have the portfolio of the action, so let's make a function. Calc value of portfolio self action. So have that action is the portfolio. The question is, do I have the time step? The time step is being, what is the time step? So the time step is self.current step and the most recent one. It'd be a hell of a lot easier if we had to get the most recent index here. So we've got the most recent index, and self would be current step. So that's just making sure that if you have a time series and the data points are entered in asynchronously for each axis, so I have multiple coins and I might not necessarily collect all of their values at the same time. Says, given this current time step, step in time, what's the most recent price that I have available? That's just a helper method for that. From there, once I have my index, or at least I can get the most recent value for each coin. So for coin in self.coins, that actually is a bug. Well, no, actually it's not. It's not a bug. It's a dictionary. Yeah, so get the most recent value. Once you have the most recent value, you need to multiply it by the action. So here I'm actually summing all these things. So sum Okay, so this is an array, so let's enumerate this. Sum of the values, simply return them. So now I've summed up the values, I can do this. So I think I'm just going to sum up all of this. I'm going to take the first option, so self.reward plus or equals. So it should learn to quickly maximize, or it should hopefully try and learn to quickly maximize its reward. I guess if the reward drops below 0, so if new value is less than 0, then equals true. Is there any other reason I should terminate this? No. And for now, info doesn't really equal anything. So, just going to do that. And now we have to work out what the observation is. So, the observation is the next environment state. Yeah, what is the observation? The observation at each time step is the current value. So yeah, appropriate observations. That is a tough question. Um, so I move forward in time, but how much? What is the increment in time? I guess let's increase the current step. Self dot current step plus or equals 1. And then let us get okay, so yeah, let's get the current environment state. So that function doesn't exist as it stands. So yeah, okay, so what's going on here? Let's just track back and think about this. So 1, so get that's the thing we just incremented. 2, from that current iron time step, so I'm just calculating the values of all the coins and storing them in a list. So loop through the list of string of coin names, access the appropriate coins data. So this doesn't really get the current time step. This is using the new current time step, get the most recent index. And actually, for this has got to go here. Okay, as does that. So now I'm appending most recent values. Return these as observations. Seems it's that simple. Yeah, okay, cool. So let's do a sanity check, because I actually haven't ran any of this code yet. So yeah, let's instantiate an object. Okay, so numpy is not defined. Fair enough. Generate random time series is not defined. Because it's not. It's that. There we go. That should be self. Okay. Type reload. History length. Fair enough. So what is history length? That should be, that's how long a time series we'd like to create. I mean, I guess that's going to be the step limit anyway, isn't it? So just setting the, yeah, so self.step limit. Great. Okay, so we have a working env. Working, in fact, it does it works. The constructor works and the reset method works. So one other thing this should do, really, is return observation. So now I'm not going to call self.reset here. It's up to the user to do that. Cool All right. Common Python error. Let's try that again. Unsupported types, int and tuple. So bear in mind I've built this environment class without even running it once, so I'm just working through all the mistakes that I made. So it's saying this is an int, this is a tuple, which is true. You just get most recent index. Go. So this is an interesting problem. This method gets the most recent index. To do that, takes a current coin and a time value. Works out the absolute distance. It says, okay, given my current time value and minus the entire array over that, pass that through a non-linearity of a ReLU, basically. So the time value is always going to be greater. Yeah, so this isn't going to work because it won't be able to get the 0th index. So what I should probably do is a quick hack. I'll come back to that. So if I do that, do I find that it works? Yeah. Okay. Okay, cool. So let's print out the state. So that's the values of my 4 coins. I could then make an action. So this has to add up to 1. So do 0.5, 2, 2. Probably has to be a numpy array as well, actually. So let's just do that. Here's where it blows up. Has no value called old values. So this is in calc transaction cost. Old values. Yeah, it doesn't have any old values, I don't think. So old values clearly is a dictionary. So let's just add it in at the top. I'll put it in here first. Self dot old values dot clear, because we need to clear it. So that is an error because I just introduced this new thing, which wasn't the wildly most clever idea. So let's just store this. So it has no get values of coins. So let's try again. Get value of coins. Okay, cool. That looks to be working, which is great. So essentially now the reward doesn't take into account the Sharpe's ratio. It does maximize the portfolio. So I guess the next thing to do is look into Sharpe's ratio. Which I don't actually know what Sharpe ratio is. Give me the code. Gimme. So the Sharpe ratio is useful for working out how risky your portfolio management bot is, and where essentially it would seem, with my limited understanding of how all of this financial stuff works, is that you are interested in two things. One, obviously maximising the profit that you're going to make, and two, you're going to want to try and reduce the risk or the amount of money it loses before it has to make money. So that's like your deviance, standard deviations from the norm of the market. So we just need to find a sensible implementation Maybe it's not that important right now. I think we can add that in as we need. I'm not entirely convinced that the Sharpe ratio is useful, because the figure is completely independent of how much money you make that it returns. It just says, okay, you made this much money and you had this much variance, so you get this result that's independent of the number that you're trying to maximize. And I just don't know how useful that is. You kind of want a value that says, great, you made loads of money and you also you weren't very risky, not too, you need you need like one number rather than two like completely independent numbers, because then you've got like multi-target optimization. That just seems much more complicated, I think, in many ways. So yeah, I'm gonna forget about that for now. Okay, so I guess this is all pretty much sorted. Probably best to go through and comment all of this. So it's configured to work like an environment. From OpenAI Gym. Okay, so what is our init function doing? So that's something I haven't implemented yet, but I will, and that's going to grab loads of sentiment data. Discrete. So this will allow the user to optimize the weight action space in it as a discrete search space, which isn't ideal, but you know, this is such an unexplored problem that it seems silly not to offer the option, if that's, you know, because it could turn out that that's a better thing. So at the moment we're passing in portfolio weightings that's a floating point, but you could make that a non-continuous, a discrete search space. Do we want a discrete? Move. So what are the arguments doing? So the arg so the argument is an array. I don't see why it should have to be an array. I feel like what it should actually do is we should just do action equals np array. There we go. Stops the user from having to do any extra crap they don't need to do. So the action is a one. So this returns 4 things. finish the environment when we have stepped over all the maximum amount of steps that we generated. Actually, that's not a private method, is it? The reward. I kind of like those comments. Maybe get rid of them later. But I kind of like them being there now. So what's reset doing? So I could have a method here that checks the action values, which I think is useful. And what this is going to do is this is going to sum up all of the portfolio weights in the action and throw an error if the action doesn't add up to 1, because that's what we want to make sure we are doing, and if we're not doing that, we definitely want to know about it. So mp.sum. Cool. So we just do if mp.sum action does not equal 1.0, raise value error. Cool. Yeah, I mean that's right. If the axis is 0 or none, sorry, sum all the elements. Great, that's what we want. So this returns, do I write it? Yep. This returns an observation, which I've already written that out. It's not really new, it's the initial time step. Cool. Render doesn't exist yet, so that's going to be a method to display what's going on in the environment. Get value of coins. So I think all these private methods are going to be changed out as we go along, so I think I'm gonna call it a day there and go have some lunch and plan out what I'm gonna do next. Cool, okay, so we're gonna take a quick break. Catch you all very soon. Thanks for watching.